Hello, this is the video for Chapter 10, Lesson 1. So in this lesson, we are going to be talking about the opposite of quadratic formulas. I guess in our last chapter, we looked at this ax squared plus bx plus c type of equation. And what was special about this type of equation was the square exponent with our variable. Well, the opposite of squaring is to square root. So what we're going to look at is what does a graph look like when it has a square root function? So I filled out some of these fill in the blanks for you already. You can pause the video and write these down if you need to. A square root function contains the square root of a variable. Square root functions are a type of radical function. Remember, radical is just the way we describe basically a square root. I guess this would be root of square root of 3 to square root of 2, or like the opposite of square. But if we, there are other radicals as well. So I guess that's a conversation for the future. But the expression under the radical sign is called the radicand. So the x under the square root sign would be called the radicand. Okay, that's what that would be. Now, what would that look like? So what would a square root function look like on a graph? It would basically look like the standard function, I guess, would kind of look like this, kind of like a curving outward to the right type of graph. So like half a horizontal parabola, I guess, and it's curving out to the right. This is the standard. So the parent function is square root of x, and it's a curved graph. And we can see that the domain, meaning the x values, it does not go beyond 0 to the left. So x is always greater than 0, and y is also always greater than 0. So this is part of the domain and range for the parent function. So you can see like there is nothing, no part of the graph that is over here to the left of my dot here, and nothing below. So that would be x is greater than 0 and y is greater than 0. So let's just kind of experiment a little bit. What if we have, 4 times the square root of x or 6 times the square root of x? What would our graph look like? So the easiest way, the quickest way, or not quickest, but like the most standard way to graph is just to plug in your x and y's. And so like your x here, and actually I might move this over so that we have a little more room for the y. So x would be here and y would be here. And let's say I have a 0, 0, okay? So our equation would be like 4 times square root of 0, which would end up being 0, right? What if we pick the number 1 for x? The input is 1, and so we'd have 4 times square root of 1. Square root of 1 is just 1, so 4 times 1 is 4. And then the x value, let's say if we pick 4. So I'm strategically picking numbers I know are going to give me whole numbers when I square root them. So I could do like 4 times square root of 4, right? Because I'm replacing my x value. So this is like the standard equation right here. Give you a little peek here. So square root of 4 is 2. That would be 4 times 2. So 4 times 2 is 8, okay? That's 4 times 2, okay? So let's just graph what I have here. I'd have a 0, 0. I'd have a 1, 4. And I'd have a 4, 8 would be like way up here. I know it's kind of hard to graph this, but it would look kind of like this. This would be what my graph looks like. All right, so let's take a look at this 6 times square root of x. So let's pick with 0. 6 times the square root of 0 would just be 0. So it'd be 0, 0. And then let's do like 1 and maybe um, 1 as our input. So this would be square root of 1. 6 times square root of 1 is just 6. And so my graph, I'm not even going to be able to fit this on here because it's going to be 0, 0, and then 1, 6, which is way up here, and it's going to kind of be stretched out. And it'll look kind of like that. Okay. So let's talk about if we can understand our equation, we can actually predict what our graph will look like without having to make a table every single time, because I don't know if you're like me, but it is kind of a pain to have to put in a table and kind of basically work out 3 equations every single time. So let's just break down some of this equation. Now, transformation of a radical expression has this h, k, and a. And so you can see that the standard form is where it's just square root of x. Well, what's different between these 2 equations? We've got a minus h, we've got a plus k, and we've got a times a, all in this equation. And each part of these variables means something. So the first part is the h. If the h, this basically tells us if it's going left or right. So if the h is positive, so that's not including the subtraction sign. That's only looking at the h. So if the equation says x minus something, then it's actually moving to the right. If it says x plus something, that means that the h is actually negative, because subtracting a negative makes the minus a negative makes it an addition sign. We can put those 2 together. So if it is a negative, it's moving to the left. If it's a positive, it's moving to the right. If the k itself, so we're not looking at the plus sign, it's just the k itself. If that's positive or negative, that's also telling us the direction it's moving. And this is going vertically. So this is going up or down. Okay. So as you can guess, that if it's going up, the k itself will be positive. Going down, the k itself will be negative. Then we have the a. This is the stretch. Okay. This is basically if it is going to become wider or more narrow. And we can read here, if a is greater than 1, the graph is vertically expanded. If a is less than 1 and less than, but greater than 0, so that means like a decimal or a fraction. So examples would be like 1/2, or 1 or 2/3, or 4/7. So these are all less than 1, but they are also greater than 0. That is where the graph is vertically compressed, okay? So it's becoming more narrow. Expanding means wider, compressed means more narrow. So let's see if we can kind of think through what this will look like without having to, I guess, work through a table. We will still have to make a table, but at least we will see kind of where this is going. So this is at a -2. This negative also kind of tells us something. This negative in front of the a tells us if it is going to be flipped around, okay? So you can also do like the -a. This means that your graph is now kind of flipped around. Normally we're going kind of curving upward and out, whereas this one is curving downward and out. So This looks like it's greater than 2. It's negative 2 times x squared, or square root of x. So it's going to be, I think, a little widened. It's going to be expanded. So let's just use a table and graph. This will help us out a little bit to be more accurate. So 0 is not going to change. That's still going to stay because we have negative 2 times 0, basically. Then let's pick, like, we could pick like the number 1 to put in here. Negative 2 times square root of 1 is just 1 times negative 2. So this would be negative 2. And then let's pick a number that can be square rooted, perfectly. So this would be negative 2 times square root of 4. Square root of 4 is 2. So 2 times negative 2 is negative 4. So now when I graph this, I have 1, negative 2, and then 4, negative 4. So you can see in our standard graph, I think it was like a 0, 0, 1, 1, and then a 4, 2. That would be like the standard parent function, whereas the curve is widening. It's not as like squished, kind of a greater, more gradual curve. Over here, we can also see that this is a negative, which means it's going to point downward. And it's going to be even wider because this number is even bigger. It's a 4. So we've got x and y. I know it's going to start at 0. That's not going to change. It's not moving left or right. And then I'm going to pick my variables to put in here. So this is negative 4 times 1. This is negative 4. Negative 4 times, let's do another 4 here. Square root of 4, which is 2. So this is negative 8. Okay, so here when I look at this, it's going to be 1, negative 4, and then 4, negative 8, which is like way down here. And so this is even wider, as you can see, compared to number 1 that we just did. It's kind of hard for me to make these curves here. But this is even wider, okay? There's your graph. All right, 3, we have a minus 4. And so if you have a operation happening outside the square root, this means it's going vertically, a vertical change. And we can see that the standard equation, if we look up here, is a plus k. And so if we see that this is a negative k, negative 4, that means what you have, k equals negative 4, which means it's going down 4. Nothing else is changing though. So really you have a standard, let's say I have a standard parent function that we graph. You can see the front of your page and see that. And then this whole thing is moving down 4. So really I'm going to put that right there. And it's nice that I can just kind of move it down, right, with my handy dandy computer technology. And we can double check, right? Like if I plug in my equation, I have my x and y, and then I have my 1, and then I have plug in 1 minus 4. And so 1 minus 4 is negative 3. That's right here, negative 3. 1 and negative 3. Let's try 4. So this would be square root of 4 minus 4, which would be 2 minus 4. That would be negative 2. And so I have 4, negative 2. And I need to move that down, just shift it down a tiny bit with my, I think I just am shifted off a little bit. I think that's better. So that is my curve. I just had to move it down 4. Now, if we have an operation inside the square root, inside the radical, we want to take a look at what's going on now. This is a plus 3. So the standard equation is a times x minus h. So we talked about this earlier. If that h, if it's plus h plus 3, that means this h is actually a negative 3, because the only way that we would have an addition sign if it was x minus negative h. And when it's x minus negative h, this becomes an x plus h. Does that make sense? So that means this is, h is my horizontal change. It's moving left and right, and it's a negative 3, so I'm going to the left 3. So again, my standard parent function looks kind of like this. I'm just going to start doing this here. and it's moving to the left three. So I'm actually going to move this over to the left three. It's not going up or down, so I can keep it there as is. Um, and you can always graph to check, right? Or make a table to check. Over here, we have a little more going on. So we've got this -1 outside our radical. And so my k is -1, which means it is going down 1. My stretch is 1/2. So if I look back above, if it is between 0 and 1, then the stretch is actually being compressed. So it's going to become kind of more narrow, not as like wide of a curve. It's going to be like a smaller curve. And so I don't know off the top of my head just what 1/2 times square root of x minus 1 would look like. So I'm going to make a table. And I do know one thing is that instead of starting at 0, 0, it's going to go down 1. So actually this will be my starting point. And I could plug that in, right? Like I could put 0 in here and see what happens. It would be 1/2 times square root of 0 minus 1, which would be 0 times -1. So this would be -1. Then I'm going to plug in another number, maybe 4, because I know that that comes out as a perfect number when I square root it. So 1/2 times square root of 4 minus 1. Square root of 4 is 2. 2 times 1/2 is 2. 2 minus 1, or sorry, 2 minus, let's work this out here. 1/2 times square root of 4 minus 1. So 1/2 times 2 minus 1. 1/2 times 2 is 1. 1 minus 1 is 0. So yes, maybe working it out on the side will help us here. 0. So that means 4, 0. And if I wanted to pick another point, I could, but it's probably going to go off my graph that I have. So this curve is it's compressed, less like curvy and wide. Let's look at another example. This -1 means that h is actually a positive 1, so it is going to the right. And this negative means it's flipped. The 2 means it's being stretched out. And off the top of my head, I probably don't really know how this is going to look. I know it's going to be stretched out, but I don't know how much. So I know I'm gonna start probably at right here because it's moving to the right. So you can always use 0 as your input for x to check your y to see where the starting point is. But I'm gonna pick, let's pick like let's say 2, because I know I'm gonna have to subtract something. So I'm thinking ahead and I'm thinking -2 times 2 minus 1. So this becomes -2 times square root of 1. Square root of 1 is just 1, so this would be -2 here. Let's pick, so I'm thinking ahead again. Normally I like to pick like 4 or 9 numbers that can be square rooted very well. But if I put like a 4 in here, then I'll have a square root of 3, which does not come out to be a perfect number. So I'm going to put an input of 5 so that when I subtract the 1, it's 4, and that becomes something that is a perfect square. So -2 times 2, which this would be -4. So let's plug these in. 2, -2, and it's confirming, as I'm graphing this, it's confirming that it's flipping upside down, and it is widening. Hard to graph these on my computer. Anyway, so that is the curve there. It's stretched. It's a stretched out curve. Okay, so that's the basic idea. Really being able to interpret and understand this transformation of a radical equation, understand the A the H, and the K, what that does to a graph will help you significantly not feel overwhelmed by graphing it and having to come up with all those points on a table to see what it looks like, but you'll have an idea of like where this graph is going. But that's all I have for lesson one. Hopefully that makes sense, and I'll see you next time.